I'm Dr. T. Welcome to my office. So today I'd like to talk about a couple of tips in making solutions. Okay, so you're going to go in the lab, you're going to make yourself some solutions, or you're going to go in your kitchen and make yourself some solutions. It's the same thing basically, just one's food grade, one's not. Anyways, so presumably your solvent is going to be a liquid. It doesn't have to be, but it gets a little bit weird when it's not, and I'm not going to cover cases where the solvent isn't going to be a liquid, just because it's less common. Okay, so you've got your solvent, it's going to be a liquid. It might be water, it might not be water. A lot of people think that all solutions are water. They're not. Obviously, if it's something that's flammable, keep the fire away. Do all relevant safety precautions. Okay, so you're going to have your solvent, and then you got your solute. The solute is probably going to be a solid, or it could easily be a liquid, or in reality, you're actually doing a dilution. You're not really dissolving something into another. So that still behaves like it's a liquid. Okay, so in this case, if it's a solid, typically what you want to do is grab yourself a beaker. You don't want to use a volumetric flask or graduated cylinder because if things don't go right, those are a lot harder to clean. So typically you'll use those towards the end of this process. So into your beaker, you typically put a stirring bar because you're going to want to stir this up. You don't want to just dump them in and call them good. You got to stir it up, and putting a magnetic stir in there is so much easier than doing any other approach. Now there are times when you don't want to do that. You can stir it in other ways. But typically magnetic stir bar in there, put it on a stirring mantle, and then you want to add a fair amount of your solvent. So you're going to have a ballpark how much you're going to get up to. You know how much solution you want to make. Let me rephrase that. So you want to add some of your solvent. You don't want to put your solute in there first typically, because if you do that, the solute goes in, then the solvent, and some solutes, when you do that, will form this kind of crust on the top, and that will make it a lot harder to get them to dissolve. So typically you want to put in a fair amount of solvent. But here's the warning, especially if you're dealing with a large amount of solute, that solute has volume. That volume is not going anywhere. So if I have, say, a liter of water, and I want to make a liter of 50% sucrose solution, and then I add 500 grams of sucrose, I'm going to have like 1.5 liters of solution. It's going to be a good deal more than my 1 liter. So what I want to do is I want to start out with definitely less solvent than I'm going to need total, but I want to start out with a fair amount of solvent in there to start with. So obviously kind of eyeball how big your solute is looking and make sure you leave yourself a nice amount of room. So add your solute in there after you've done your solvent, and then add a bit more solvent. You want to get up to about 90% of your final volume. You don't want to shoot for your final volume because you're in a beaker. Beakers are notoriously not all that accurate. They're meant to be a glass container to do stuff in. They're not meant to be volumetric material. Now at this point, stir it. You might need to add heat, especially if it's an endothermic process. When you dissolve things, there's a whole heat of dissolving going on. So that could be endothermic or exothermic, and both have consequences. So if it's an endothermic one, quite often you want to add a little bit of heat. So turn the hot plate on. Don't go nuts. You could damage whatever you're working with if you get it too hot. But add a little bit of heat. That's going to help speed things up, especially if it's getting cold. If you know what you're working with is exothermic, then you might want to add it in batches because you don't want to get too hot. Some things, when you add them to the solvent, they're going to get hot. And that's also why you start out with a fair amount of solvent to start with. You want a fair amount of thermal mass there. If you just slop in the solvent, then the first amount you pour in is now all of a sudden going to be trying to dissolve the entirety of your beaker. Well, not really the entirety. All of it can get to. And then all of that solute can really heat up the first amount of solvent quite hot. And I've had it actually get to the point where it started to flash boil, which, seeing that the solute was sulfuric acid, was not something you wanted to flash boiling on you. So be careful when you're adding these. If you are going something that's exothermic, add it batch-wise. Just kind of slowly pour it in. Make sure the temperature doesn't get too hot because you're going to run into problems with that. Okay, you got the thing stirring, control your stir bar so it's not slopping all over the place. Make, the usual, just pick a good size stir bar for what you're doing. Okay, now that you've got this, what you want to do is, turn off the hot plate, turn off the stirring mantle, take the beaker off, take another stir bar and put it underneath your beaker. This is going to allow the magnets in them to lock them to each other. That way you can pour from your beaker into a graduated cylinder or volumetric flask or whatever else you're going to use to actually measure, and not transfer the stir bar with it. So you pour. Now, you still have material in there, so take a little bit of your solvent. This is one of the reasons why you only did about 90%. Take a little bit more of your solvent and rinse your beaker with that. That's going to allow you to get all of your solute. If you really want to be finicky, you do this a couple of times. But once again, don't overdo this because it's really easy to add more solvent. It's really hard to take it away. So now at this point, you've transferred your stuff into your volumetric or your graduated cylinder, and then you fill it to the mark. So that you add more solvent until you get to the desired volume. At which point you need to make sure you mix this again. So typically here's where you put a covering on top of your volumetric glassware and either invert it a bunch of times. So you hold the top, hold the bottom, and flunk, flunk. Parafilm's fun if it's water. Obviously, if it's not water, it'll dissolve the parafilm. Ground glass is a great stopper. Alternatively, you put it in another stir bar and you just stir it that way. It depends on what you're working with, how much you're working with. If you're working with 10 liters of something, you're not going to be doing this. That's too much weight. If you're working with, a liter or two, chunk, chunk, and then just invert. It takes a little bit of work, but you're fine. Okay, let's talk liquids. Now, in this case, we're actually a little bit more concerned about the whole exothermic thing, because a lot of the liquids you're going to be making solutions with, you're actually making dilutions with, and they're going to be things like, concentrated acids and whatnot. So the saying is always add the acid. So you're going to take your flask, if it's a liquid, and you don't have to worry about it not dissolving and having to clean the thing. Yeah, just go straight into the graduated cylinder or volumetric flask if you don't have to worry about cleaning it. Whether or not you start in a beaker is entirely your call on, do I have to worry about cleaning this dumb thing? Because beakers are easy to clean. Tall, thin things, especially those volumetric flasks, good luck. Those things are hard to clean. So what you'll end up doing, add a fair amount of the solvent that you're going to add in, and then take the liquid and pour that in. Once again, make sure right now that your volumes add up to about 80–90%, not more. You don't want to go nuts at this point. So at this point, then usually I give it a nice mix. Once again, especially if it's 1–2 liter volumetric, seal the top, up, down, up, down. Obviously depends on what's in there. If I can't make a good seal, if it's something toxic, or I'm really concerned about dropping it, maybe I won't do that. But just your everyday boring aqueous solutions, great way of doing it. Now you then take the cork off and fill it to the mark and put it back on and mix it again. And yeah, you've got yourself a nice solution. The main things to worry about are overfilling that thing. Usually you fill it fairly quick to start with, and then you kind of go drop-wise. Quite often I'll go up to the large water containers that we have in lab. I'll fill the thing up to about 75–80% of where I want to go, and then I'll switch over to the smaller squirt bottles, assuming I'm doing aqueous. If I'm doing non-aqueous system, obviously, I use whatever container is appropriate. If I've got a big old container of stuff and I need to pour into a little container, I'm going to do an intermediate beaker. So if I've got one of those big, 2.5, 5 liter containers, I'm not going to try and pour from, something that's this big into a little tiny beaker. I'm going to get myself a nice medium-sized beaker, something I can actually hit when I pour, and then pour into it. Beakers typically have spouts. Funnels are overrated. Use them if you want, but typically they are a bit overrated, and you're usually better off, instead of trying to use a funnel, that usually means you're using too big of a thing to pour into, so you should go into an intermediate size thing. It's just more controllable in those cases. That said, funnels exist for a reason, so, don't get me wrong. So with that said, that's a couple of tips on making solutions. As always, be safe and make sure you stir. Talk to you later. Have a wonderful day.